For this triangle here then, the first thing you've got to think about is how many of the squares that are made up of 4 triangles you can cut out of this bit of paper. Your original bit of paper is 1189 long and 841 high. Because each of the squares is 200 long, I can fit 5 of them along. Because this is 841 high, I can fit 4 going up. So there are 20 altogether there. So I can cut out 20 squares, which, because there are 4 triangles in each one, equals 80 triangles. But I've got this strip left over that's 189 by 841, and I need to know how many of the little triangles I can fit. Now I'm thinking if I put them in squares like this, the squares will be smaller. But I need to know how big those squares are, those triangles are. If one of the squares that has 4 triangles in it is 200 by 200, then the area of that is 40,000. So one of the triangles will be 10,000. It's a quarter, there's 4 of them there. So my new square that I'm making out of 2 is 20,000. And to have got 20,000 from timesing 2 things together, I will need to know what the square root of 20,000 is. I'm going to get that on my calculator. And that's 141.42. So that means my new squares are 141 centimetres wide. So if you look at the strip that I have here, is great because it means I can fit 1 going along, and I can fit 841 divided by 141, which is 5.9, but most importantly it's not 6, so I can only fit 5 of them going up this way. So I can fit 5 squares going up, which is 10 triangles. So altogether I've got 80 triangles here and 10 triangles there, which is 90 triangles altogether. Question 8 is a trig question, you just don't have the triangle there. But if you've got a side of a house that you're leaning a ladder up against, then it's going to make a little right angle triangle like that. It says it has to reach 3.8 metres up, and to be safe it has to be at an angle of 72 degrees. Suddenly this looks a lot more like a normal trig question. We want to know the length of the ladder, so that's this distance, put x there. Opposite, adjacent, hypotenuse, these 2 are needed, this one's not. So if we write out saw, car, tower, the A isn't needed, so it's sin. So sin, 72, opposite on the top, h on the bottom. So sin 72, 3.8 on the top, hypotenuse on, well, x on the bottom, the one we're looking for, so it's a divide. So 3.8 divided by sin 72, type that in on your calculator. It's 3.995. So what we're going to say is it's going to be safe. We need a 3, well, if we round that to a sensible amount, it would be 3 and 2 decimal places, but if we round it to 2 decimal places, it's going to be 4. I'm going to call it a 4 metre ladder. Question 9 starts off as a substitution question, so 2 is equal to 2 times pi, which is 3.14, times the square root of L we don't know, G is 9.81. So 2 is 6.28 times L over 9.81. We've then got to move this around until we've got L on its own. So we're going to divide by 6.28, which will leave me with that. Then we're going to have to square it. And that'll leave me with L divided by 9.81. And then we're going to times by 9.81. And I'm going to type this into my calculator. which is 0.9949637. I would write everything down. Part B is very similar. In fact, we've already done it to work this out. So we've just got to do it with letters instead of number. So we had t is 2 pi square root of L over G. So we're going to do exactly the same process but with the letters. So we started by dividing by what we got here. So that was 2 pi. So I'm going to do t divided by 2 pi. Notice I've used a fraction instead of a divide. It means the same thing. That leaves me with L over G. I then squared it because it's the opposite of square rooting. So t over 2 pi squared. That leaves me with L over G. Then I've got to times by G. So it gives me G times t over 2 pi squared is L. That's it, done. Okay, for question 10 we've got to solve the algebraic fraction. Some of you might just have learned that you cross multiply to get these off the bottom, but basically we're going to multiply by x plus 3 to start with to get rid of that off the bottom. That gets me that. I'm then going to multiply by x plus 4. So it'll get rid of that one and it'll give me this one multiplied by x plus 4. Notice I put brackets around things before I multiply them. I'm then going to expand most of these things. So x squared plus 3x. Remember, use your brackets if you need to. X plus 3, use your grids. The second one, x plus 7 and x plus 4. X squared, 4x, 7x, 28. So that's x squared plus 11x plus 28. I'm then going to have to remember that to solve a quadratic I need it to be equal to 0. So I'm going to work through now to get to there. I'm going to take away x squared. And that's actually quite nice because if I take away x squared, these disappear. So it becomes a non-quadratic. So let's go carry on anyway. So if I take away x squared, leaves me with 3x here is 11x plus 28. I'm going to then take away 2x because that side's got more letters on it. Sorry, take away 3x. And I'm going to take away 28. That's minus 28 is 8x. So all I need to do to finish off is minus 28 divided by 8 on a calculator, which is minus 3.5.